Hello friends, in this class we will be learning how to derive equations of motion, the three equations of motion by graphical method. So let's take a quick look how it can be done. Equations of motion. There are three equations of motions, that is V is equals to U plus AT. Second one is S is equals to UT plus half AT square. And third one is V square minus U square is equal to 2AS. Okay. Let us say, let a body be moving with initial velocity u and accelerates in time t, changing its velocity to v. Graphically, if you wish to represent this statement, then we would say it is x-axis independent quantities like time can be plotted, time in second, let us say, or velocity here. So I said that initial velocity of the body is u. Now it has to undergo acceleration. So it is accelerating from this point u. It has started changing its velocity to v. So if I consider this point as OA, O I have taken here A, then B, then C and D. Means this is initial velocity the body has. It has started changing its velocity. So here we find between B and C there is change in velocity. This one is final velocity. This one is initial velocity. So this portion will be V minus U. This is change in velocity. Now, let us take first part. First part is V, how to derive. V is equal to U plus AT. From the graph you can understand that acceleration can be calculated from slope of AB. We can calculate, and formula for slope is change in y-axis, that is BC by AC. BC by AC. And what is BC? BC is BD minus CD. BD minus CD by AC. BD is V minus U because CD is U divided by AC is time, and this acceleration symbol we can put A here also. Now cross multiply A into T. A T is equals to V minus U, or you may write U plus AT is equals to V. This is the first equation which we have derived. Now from the graph, second equation can also be derived. If you see here, s is the distance traveled. Now, distance traveled, second part. Distance traveled. Distance traveled can be given by area of OABD. OABD. Here, if you see carefully, it is a rectangle and a triangle. So, distance traveled, we will suppose a distance traveled, that is S is equals to area of a rectangle OACD plus area of triangle BCA. So area of rectangle, that is length into breadth, or we can write OA into OD. OA into OD plus area of triangle, so it is half into base into height. Half into base. Base is AC into height is BC. Okay, this implies S is equal to OA. You can see here OA is U into OD is T plus half into AC. AC is time into BC, that is V minus U. V minus U. Further, you can change this portion from equation 1, V minus U, that is equal to AT. So, here we will put S is equal to UT plus half into T into AT. So finally we get S is equals to UT plus half AT square. This is second equation we have derived. Now third equation, that is the relation between velocity, acceleration and distance traveled. So here also distance traveled is given by area of trapezium. Here we'll take, if you see here, these are parallel, OA parallel to DB, and this one is height OD. Therefore, area of trapezium DOAB. Now, S, that is distance travelled, is S. So S is equal to area of trapezium half into sum of parallel sides into height. So this implies S is equals to half sum of parallel sides. You can check OA plus DB. OA plus DB into height is OD. Let's put the values in terms of velocity and time. You will get half sum of parallel sides, that is u and v, or u plus v into OD is t. Here again you will make changes. V plus u, for our convenience to use in formula, we will write v plus u. In place of t, suppose you take this side and a you make it as denominator, it will be v minus u by a. V minus u by a in place of t. So here I will write t is equals to v minus u by a. So we can write s into 2 into a, this denominator and this one will get cross multiplied. So we can write 2as is equals to a plus b into a minus b. So v square minus u square. So here we get third equation. So this is how you can derive three equations of motion for the objects moving on a horizontal plane. Three equations of motion by graphical method. This is the way you can derive. Okay. This is short video related to equations of motion. Thank you for watching this video.